Welcome to my channel. Now we are consisting of unit step function v of t equal to 1 for t greater than 0, 0 for t less than 0. Unit step function is not continuous and differentiable at t equals 0. Mathematically, u of 0 equal to half average value. Product x of t into del of t minus t naught equal to x of t naught into del of t minus t naught. That x of t becomes x of t naught. Sampling function. Integration of t1 to t2 x of t del of t minus t naught equal to x of t naught. Relation between unit impulse and unit step function u of t equal to integration of minus infinity to t del of t dt and del of t equal to du of t by dt. Du of t by dt. Tri of t by tau equal to 1 by t small t plus 1, that minus t less than equal t less than equal 0 minus 1 by capital T into small t plus 1, 0 less than equal t less than equal to capital T, 0 otherwise. That is called as a triangular function. Whereas rectangular or gate function equal to recta of t by tau equal to 1 for minus t by 2 to t by 2, 0 otherwise. Signum or SGN function. Signum function SGN of t equal to 2 into u of t minus 1. Remember, there will be two step functions u of t and minus u of t. So the signum of t equal to 2 into u of t minus 1. U of minus t equal to 1 minus u of t. Signum function is not defined at t equals 0 and is chosen as 0 at t equal to 0. The sinc and sinc square functions are defined in terms of an independent variable lambda. Sinc of lambda equal to sin pi lambda by pi lambda. Sinc lambda is equal to 0 for lambda equal to plus or minus 1, plus or minus n not equal to 0, n is an integer. Sine integral function is an odd function. Si of y equal to integral of 0 to y sine of alpha by alpha d alpha. Si of y equal to y by 1 into 1 factorial into 1 minus y cube by 3 into 3 factorial plus y power 5 by 5 into 5 factorial minus y power 7 by 7 into 7 factorial and so on. Si of 0 equal to 0. Si of pi is nearly equal to 1.8519. Si of infinity equal to pi by 2. SI function converges fast and only a few times in above equation are needed for a good approximation. Time scaling. Let x of t be an arbitrary signal. A time signal version of x of t is obtained by replacing t by at, where a is a scaling factor. Phi of t equal to x of at. A greater than 1 shows compression of x of t. 0 to a to 1 shows expansion of x of t. Phi of t equal to x of t minus t naught. Delay or shift right by t naught. Phi of t equal to x of t plus t naught. Advance or shift left by t naught. Time shifting discrete signals. Same. Phi of n equal to x of n minus n naught. Delay or shift by n naught samples. Phi of n equal to x of n plus n naught. Advance or shift left by n naught samples. Priority shifting greater than scaling greater than reversal. There is no effect of scaling on unit step signal. Time scaling on ramp signal will result into magnitude scaling as R of at equal to a into R of t. The product of two even signals or two odd signals is an even signal. The product of an even signal and an odd signal is an odd signal. Remember, the product of two even signals or two odd signals is an even signal, whereas the product of an even signal and an odd signal is an odd signal. For complex valued signal x of t equal to x conjugate of minus t, even conjugate or conjugate symmetric, x of t equal to minus x conjugate of minus t, odd conjugate or conjugate anti-symmetric. Remember, for a real valued signal, even part if you want to determine, then you have to calculate the formula x of t plus x of minus t by 2. For real valued signal, in discrete time, x of n plus x of n minus 2 for even part. For real valued signal, odd part, x of t minus half x of minus t by 2. Whereas in discrete time, for odd part of real valued, x of n minus half x of minus n by 2. Energy of the signal E equal to integration of minus infinity to infinity x of t square dt equal, that implies discrete time E equal to integral E sigma n equal to minus infinity to infinity x of n whole square. Average power of a signal equal to P equal to limit t tends to infinite 1 by t integration of minus t by 2 to t by 2 x of t square dt equal to limit n tends to 1 by 2n plus 1 sigma n equal to minus n to n x of n square. Yeah, an energy signal has zero average power always. A power signal has infinite energy. Signal having infinite duration with their value tending to a non-zero constant as t tends to infinity, and signals which are periodic or in general power signal as t tends to plus or minus infinity. If amplitude tends to zero, it is neither energy nor power signal. Finite duration bounded signals are energy signals. Energy of a signal is only affected by a scaling operation as E of at equal to E of t by a. Power is not affected by time scaling, reversal, or shifting. The fundamental period for analog signal is T naught equal to 2 pi by omega naught. For discrete signal, N by capital K equal to 2 pi by omega naught, where K equal to 0, 1, 2, 3. The fundamental period T naught of x of t and the N of x of n in the smallest positive integer for which above equation holds good. Sum of two continuous time periodic signals may not be always periodic, but the sum of two discrete periodic signals is always periodic. If two continuous time signals having period t1 and t2, then for their sum to be periodic, t1 by t2 should be a rational, and the period of the sum is given by t equal to LCM of t1 by t1 comma t2. If two discrete time signals having period n1 n2, then the sum is always periodic with period n equal to LCM of n1 comma n2. For a periodic signal x of t, the average value of the signal equal to x average equal to 1 by t integral of x of t dt. The average signal power equal to px equal to 1 by t integral of t x of t t square dt. Effective or RMS value of the signal x RMS equal to root px, where xt of t equal to 1 period of x of t. RMS value of A cos omega t plus phi is A by root 2. With DC offset, RMS value of A naught plus A cos omega t plus phi is root of A naught square plus A square by 2. Odd half wave symmetry x of t equal to minus x of t plus or minus t by 2. Remember, odd half wave symmetry x of t equal to minus x of t plus or minus t by 2. Even half wave symmetry x of t equal to x of t plus or minus t by 2, where t is a period of x of t. Classification systems, linear systems and non-linear systems. When systems satisfy principle of superposition and homogeneity is called a linear system. Else non-linear system superposition x1 of t it is y1 of t, x2 of t is y2 of t, then x1 of t plus x2 of t equal to y1 of t plus y2 of t. Homogeneity a into x1 of t plus b into x2 of t equal to a into y1 of t plus b into y2 of t. Of linear systems, y of t equal to a into x of t, y of t equal to integration of minus infinity to x of t dt. Time invariant and time varying systems. A system is called time invariant if a time shift in the input signal causes the time shift in the output signal. X of t tends to y of t, then x of t minus t naught gives you y of t minus t naught of. Example of time invariant system equal to y of t equal to x of x square of t. Once again I will repeat. A system is called time invariant if a system is called time variant if a time shift in the inputs causes the same shift in the output. If x of t equal to y of t, then x of t minus t naught equal to. Example of time invariant system is y of t equal to x square of t. Causal and non-causal systems. The output of the causal system at the present time depends on only the present and or past values of the input, not on its future values. A system is called non-causal if it is non-causal. If it is not causal. An example of a causal system, y of t equal to x of root t. All memoryless systems are causal, but not vice versa. Causal systems are referred to as non-anticipative, as the system output does not anticipate future values of input. A system is said to be static or memoryless if the output at any instant depends on only the input at that instant. Otherwise, the system is dynamic system with memory. Example of static system: y of t equal to into x of t. Stable and unstable system. A system is bounded input, bounded output, that is BBO stable. If for any bounded input x of t, the corresponding output y of t is also bounded. Example of stable system: y of t equal to e power x of t. A consequence of the homogeneity of linear system is that a zero input yields a zero output. Invertible and non-invertible systems. It is possible to define an inverse system of a given system. Then system is invertible. Otherwise, it is called non-invertible. Y of t equal to integration minus infinity to x of t dt. Invertible. Y of t equal d by dt of x of t is inverse system. Convolution. The convolution integral or the superposition integral represents a continuous time invariant time invariant system in terms of its response to a unit impulse. Continuous time LTA system. Continuous convolution of two functions x1 of t and x2 of t. Y of t equal to x1 of t convolution with x2 of t equal to minus infinity into x1 of tau into x2 of t minus tau d tau, that equal to minus infinity into x1 of t minus tau x2 of tau d tau. If two analog signals gets convolved, the resultant of convolution of two signals will have a width equal to the sum of the individual width of the two signals being convolved. The lower extent of resultant signal will be equal to sum of individual lower extents L equal to L1 plus L2. Similarly, upper extent is a sum of individual of upper extents U equal to U1 plus U2. The area of resultant convolution is equal to the product of the area of the signals being convolved. Properties of convolution integrals. Commutative property y of t equal to x1 of t convolution with x2 of t, x2 of t convolution with x1 of t. Convolution of two delayed functions y of t equal to x1 of t into convolution of x2 of t, x1 of t minus t1 convolution with x2 of t minus t2 equal to y of t minus of t1 plus t2. Very, very important. Y of t equal to x1 of t convolution with x2 of t, x1 of alpha t convolution with x2 of alpha t equal to 1 by modulus alpha y of alpha t. Special cases. Phi of t convolution with del of t equal to integral minus infinity infinity phi of tau del of t minus tau d tau equal to phi of t. Del of t convolution with del of t equal to integration of minus infinity infinity del of tau del of t minus tau d tau equal to del of tau. Discrete LTA systems. Y of n equal to x1 of n convolution with x2 of n equal to sigma k equal to minus infinity infinity x1 of k x2 of n minus k that equal to x sigma k equal to minus infinity infinity x1 of n minus k x2 of k. If two discrete signals gets convolved, the resultant of convolution of two signals will have a length equal to the sum of the individual length of the two signals being convolved, the minus 1, that is L1 plus L2 minus 1. Resultant of convolution has extent to equal to the sum of the individual extents of the signal being convolved.